Hello everyone, welcome to this video. In this presentation, we are going to learn about graph traversal, one of the most important concepts in data structures. We will understand what graph is, what graph traversal means, and study two major traversal techniques, breadth first search and depth first search. Graph traversal means visiting all the vertices of a graph in a systematic manner. Since graphs do not have a fixed starting or ending order, we use traversal techniques to ensure that every vertex is visited efficiently. The two main graph traversal techniques are breadth first search, commonly called BFS, and depth first search, called DFS. What is graph? A graph is a collection of vertices, also known as nodes and edges, which connects these vertices. Graphs are used to represent many real-world systems such as road networks, social media networks, and computer network. Each vertex represents an entity and edges represent the relationship between them. What is graph traversal? Graph traversal is the process of visiting each vertex of a graph exactly once. Traversal is necessary for tasks such as searching data, finding path, and analyzing the structure of graphs. Because graphs do not follow a linear order, we need systematic algorithm to traverse them. Types of graph traversals. There are two major types of graph traversal techniques. They are breadth first search or BFS and depth first search or DFS. The main difference between BFS and DFS lies in the order in which nodes are visited. Breadth first search. In breadth first search, we visit all the neighboring vertices first before moving to the next level. It follows a level by level traversal approach. BFS uses a queue data structure which follows the first in first out principle. Breadth first search algorithm. Let us understand the BFS algorithm step by step. First, start from the given source vertex and mark it as visited. Next, insert the source vertex into a queue. While the queue is not empty, remove the front vertex from the queue and visit it. Then, for each adjacent unvisited vertex, mark it as visited and insert it into the queue. This process continues until the queue becomes empty. Then, depth first search. Now let us look at the depth first search algorithm. Start from the given source vertex and mark it as visited. Visit the vertex and select any unvisited adjacent vertex. Recursively apply DFS on that vertex. If no unvisited adjacent vertex exists, the algorithm backtracks. This process continues until all vertices are visited. Breadth first search versus depth first search. The comparison. In BFS, nodes are visited level by level, whereas in DFS, nodes are visited by going deep into the graph before backtracking. BFS uses a queue, while DFS uses recursion or a stack. Both algorithms have their own advantages depending on the problem being solved. The next, time complexity. The time complexity of both BFS and DFS is O of V plus E, where V represents the number of vertices and E represents the number of edges. This means both algorithms are efficient and scalable for graph traversal. Real world examples. Graph traversal techniques are widely used in real world applications. Social media platforms use graph traversals to suggest friends. Maps and navigation systems use BFS to find the shortest path. Artificial intelligence systems use DFS for decision making and problem solving. To summarize, we'll learn what graphs are, what graph traversal means, and explore BFS and DFS in detail. These traversal techniques form the foundation for many advanced algorithms in computer science. Thank you for watching.